Hello and welcome. We just got done talking about factoring quadratic expressions, ax squared plus bx plus c, where a is 1. Now let's look at a is not equal to 1. If a is negative, I'll factor out the negative out of all the terms to make the leading coefficient on the x squared a positive number at least. But if it's not 1, we can do some kind of guess and checky, trial and error type stuff to get it. Sometimes it's easier than others. So I'll give you an example here. 3x squared plus 4x plus 1. Let's factor this. Well, let's just kind of set up our binomials. We know that this would have to be 3x and this would have to be x, because 3x times x has to be equal to 3x squared. So it's kind of almost backwards from before, because we know on these numbers, those have to be 1 and 1 if this is going to work at all. Right? 1 times 1 has to be equal to 1. So almost, we're basically practically done. We just got to figure out what these signs have to be. Well, just like before, this sign on the 4x tells us that they both have to be plus. This sign told us they have to both be the same sign. So that wasn't too bad. This guess and check type stuff is good for particularly easy factoring problems. 15x squared plus 2x minus 1. First, I do check to see if there is a common factor that I can factor out of all the terms. That doesn't look like that's the case here. There's a couple of choices here. We could go 1 and 15 and 3 and 5 for in front of our x's. So we got two possibilities here. And for our second term in these binomials, that's pretty straightforward. Those have to be 1. One of them has to be positive, one of them has to be negative. So we are looking at a difference of the I terms and the O terms. So we're kind of just multiply them as we go to see which one's the right way to do it. If we did plug in 1 and 15 here, we would see pretty quickly that there's no way, if say this were positive and this were negative, we get a 1 or a negative 1 and a positive 15. 15 minus 1 is 14. That's nowhere near 2. So we can be pretty sure that those aren't going to cut it. So then we try 3 and 5. And I don't know if it's plus here and minus here or minus here and plus here, but that's determined by this sign here. Instead of looking at the sum of these two of the ones, we have to look at the sum of the O and the I terms of the FOIL, the X terms, the terms that sum up to the BX. Well, in this case, we'd have a 5x and a 3x. As long as we know it's difference, it's got to be a difference because they got to be different signs. We're still looking at difference. So we're still using those principles from before. Because of that, we know that we're looking at 3x and 5x. We're looking at the difference of those, which is 2x. So this is correct. This will work. But which one wins the tug of war? Well, it's going to be the 5x. Well, that's 5x times 1. So that has to be the positive. 3x times this one here has got to be the negative. So it's 5x minus 3x. So you almost have to do the little O and the I term multiplication. You can write it out in your or do it in your head to make sure that you get the right sign. So that's it. 3x plus 1 times 5x minus 1. That's it. Now, this can get pretty messy pretty quick. You saw we had two choices for our numbers on our x's. But what if we have many choices for the numbers on your x's and many choices for the numbers for the other two numbers? It can get kind of messy real quick. Let's look at this one. 3x squared plus 4x minus 4. Now, we can start. We know our x's have to be here. And we know that the numbers on here are 3 and 1. And we can probably just commit to that because there's really only one possibility there, 3 and 1. And I'm not going to write the 1. And then on the other one, we have to have two numbers. They're opposite signs that multiply to 4. Well, there's 1 and 4, and notice I'm writing them here instead of in our table because the order that we write these matters, because if you look at the O and the I, we're not looking at the sum of these two numbers, or in this case the difference of these two numbers. We're looking at the difference of the O term and the I term, the X terms, after you multiply those two in the FOIL process. So this would be 12x and 1x, so the difference is 11x. So, but because this isn't symmetrical, you've got one of these binomials with a 3x, the other binomials with just an x, you have to check both of them, both orders. And then the only other possible choice here is 2 and 2. So we've got three possibilities. Now some books or teachers might get into checking all possible plus and minus combinations. I don't do that. I think we know it's going to be a difference. We know they're opposite signs. We'll take care of the sign later. We know we're looking for a difference though. From this, like we said, we're looking at 4 times 3x, which is 12x, and 1 times x, which is x, and we're looking at a difference. I could leave the x off of there, but let's just be safe. So this is 11x, so that's not it. That's not right. We can't do that. For this set, we've got a 1 times 3x, which is 3x, and a 4x. Well, the difference between those, we don't really care which one's positive, which one's negative. The difference between those is a 1x, so that's not going to work either. Finally, we've got the only other possibility that we can try. If this doesn't work, then we can say this trinomial, this quadratic, does not factor. Well, 3x times 2 is 6x, and 2 times x is 2x. So the difference of those is 4x. So that's right, that's what we want. So those must be the ones. Now we got to figure out which sign is which. Turns out it is a positive 4x, so that means the 6x has to be the positive one. So that means the 3x and this 2, that means this guy has to be positive, and this guy has to be negative. Check it. 3x times 2 is 6x, positive 6x, minus 2x gives you a positive 4x. So it turns out that gives you the right factorization. And that's it. So you can see how the trial and error stuff gets kind of nutty. I have another method that works really great, and there are many ways to do this. But I do have another method that I like to use if I'm really stuck. If I might fiddle around with this trial and error stuff for a little bit just to get practice. But if it starts getting to be rough, I'll use a different method, and that's the AC method. Basically, you just need to find two numbers. Like before, it's very similar. Find two numbers that multiply not to C, but to AC. So first we figure out what AC is first. A times C. That's the first coefficient times the last coefficient, and add to B. So two numbers that multiply to AC and add to B. And with all the same intuitions that we have already. If AC is positive, then the two numbers, the same sign, which means we're looking at a sum, a flat sum. If AC is negative, then the two numbers are different signs. And so we're looking at a difference. A difference to get to B. Sum to B, or difference to B. And the signs that those are is still determined by the sign on our B. So that process is pretty much exactly the same as before. Now what we do with these two numbers is slightly different. What we do is we split up the BX term, the X term, into two terms with coefficients with those two numbers that we picked. These coefficients. Now once we have that, then we just factor by grouping. If we found the two numbers that work way up here in part 1, way up here in part 1, then then this factor by grouping will work. So let me show you how that works with this one here. So we got 3x squared plus 4x minus 4. A, B, C. So AC is negative 12. So we got to find two numbers whose product is negative 12. So we're looking at negative 12. And so since it's negative, we're looking at a difference. And we're looking for a difference of 4. And we've already seen this several times before. You could go through one. If you didn't know already what two numbers multiply to 12 and have a difference of 4, you could go through it. It's 6 and 2, right? And we could stop here. We don't have to go any further. There is 3 and 4 here, but this has a difference of 4, 2 and 6. Instead of having two binomials, what we do is we break up this 4x into two parts. We break it up into a positive 6x and a negative 2x. Why positive 6x? Because we know because this is positive and it's a difference that this 6 has to win the tug of war. I'll write the rest of it here. Now we factor by grouping. So 3x goes into these two. Let's write that. X plus 2. And now here, remember factor by grouping, we're looking for x plus 2 here after we factor out something out of these two terms. Well, what we'll have to factor is a negative 2. When you factor out a negative 2 out of this term, you divide by negative 2, you get x, positive x. Divide a negative 2 into the negative 4, you get positive 2. It basically switches the sign of both of those terms and divides each one by 2 as you pull that negative 2 out. Because we wanted an x plus 2. If you just pulled out a 2, you would have a negative x minus 2 inside, which isn't what we want. We want an x plus 2. But anyway, now we can factor out that x plus 2 out of both of these bigger terms, and you're left with 3x minus 2 here times x plus 2. And so we get the same thing. But this is a systematic way to do it that is clean. And if you remember the algorithm, then it's pretty quick after you practice a bit. As always, the difficult part is the factoring. So if this number that we have to find the factor pairs for, if it's big, it's going to take a while as we figure out what those pairs are. Let's do another one. So let's try factoring this one. Again, trial and error can be done with this. It's not too bad. You just have a couple possibilities with the 6 here. 1 and 6, 2 and 3 if you're factoring it normally with binomials. It's doable. But let's do it with AC method. AC is 30, positive 30, so same sign, sum. We've got, you could go through all of these. We're looking for a sum of 13, in particular negative 13, but we just know that the same sign, that negative means they'll both be negative. So we're looking at, you probably already see it. What two numbers multiply to 30 and add to 13? Well, it's 3 and 10. If you see it already, great. Otherwise, you'll have to go through 130, 215, 3 and 30, or sorry, 3 and 10, etc. 5 and 6, etc. But there's 3 and 10. That's what we want. So now that means it's negative 3 and negative 10x that we will split this into. 6x squared minus 3x. And by the way, it doesn't matter whether I put the 3x, the negative 3x, or the negative 10x first. It really doesn't matter. The factor by grouping will still work regardless of which one you put first. So it doesn't matter. Minus 10x plus 5. Let's look at these two. Let's factor these first two terms. Looks like a 3x goes into both of those. 2x minus 1. Right? Negative 3x divided by 3x is a negative 1. And we're looking for a 2x minus 1 on this one too. So we're going to have to factor out negative 5, it looks like. And we're left with, and that will switch the sign of both of these terms, which is what we want. And that's 2x minus 1. 3x minus 5. Factor out the 2x minus 1. And you get this. And that's it. Now I want to talk about one more thing. I want to talk about some special types of quadratic expressions that if we understand how they work, it might save a lot of work later on if we recognize them. Otherwise, they can be kind of rough. These quadratic expressions, you can factor normally like we've been doing, but if you notice the pattern, it can save a lot of time. So first, we're going to look at the difference of squares. If you see two numbers that are a difference and they're both squares, then that's a difference of squares. It looks like this, a squared minus b squared. If you see that, that automatically factors into a plus b times a minus b. In fact, multiply it back out. You get a squared, negative ab, positive ab, those cancel off, and negative b squared. So that factors. By the way, the sum of squares, a squared plus b squared, doesn't factor. Doesn't factor into real numbers. It doesn't factor with the reals, so note that. But difference of squares, it factors just fine. That middle term that you're trying to find the difference of, because you're looking for a difference, right? That middle term you're looking for as a difference is 0. So that means the two numbers you're looking for that multiply to b squared in this case would have to be the same number, just opposite signs. Let's go to 4x squared minus 9. So if you recognize this is a perfect square and this is a perfect square, we'll write down what those are. This is 4x squared is the square of 2x, right? Take the square root. And the square root of 9 is 3. So now we're just going to have 2x plus 3 and 2x minus 3. That's how you factor that. It's very quick. How about this one? Y squared minus 16x squared. Well, y squared is the square of y. 16x squared is the square of 4x. It's a subtraction, it's a difference, so this will factor. If it was a plus here, we'd be out of luck. We'd just have to say, oh, we're done. But it's a minus, so we can write this as y plus 4x times y minus 4x. That's it. The other special product, the other special quadratic is what I call, I guess, a perfect binomial squared binomial, I guess. Let's see what that looks like. So you just got a plus b squared. You can rewrite this as a plus b times a plus b and FOIL that out as you want. Turns out it's a squared plus an ab and an ab add up to 2ab plus b squared. If this happens to be a minus here, if you have an a minus b squared, it's the same deal. It's a squared minus 2a. These two are the same sign in here, so they still add up to this negative 2ab, and it's still positive b squared. So sometimes we write this in shorthand as we just put a minus here, and if that bottom, if that's minus, then that just makes this one a minus. 9x squared, 30x plus 25. Obviously, you can factor this using the AC method. It just gets to be a little bit rough. But it's not horrible. If you don't see that it's a perfect square, you can use the AC method. And let's, real quick, I could show you that. AC is 9 times 25, which is 225. Positive, right? So it's a sum we're looking for. And the sum has to add up to 30. So that tells us that looking at 1 and 225 and big numbers like this isn't going to be very useful to look at. So I'm going to look at numbers that are smaller. Well, it turns out 15 and 15 work. 15 and 15 add up to 30, and 225 is 15 squared. So then you would split up your 30x into 15x plus 15x plus 25. Factor by grouping, looks like 3x goes into both these first terms, 3x plus 5. And we're looking for 3x plus 5 over here too. Guess what? Factoring of 5 does that, 3x plus 5. And lo and behold, we get 3x plus 5 times 3x plus 5. So yeah, AC method does work, and if you're practicing it, you can be pretty quick, but not as quick as just recognizing that this is a perfect square. If the first term, the a term, the ax squared term, and the c term are both perfect squares, immediately you're going to want to think, oh, is this a perfect square? Can I save a ton of time? How you do that is you write down what are these the perfect squares of. 9x squared is the square of 3x. 25 is the square of 5. Now, all we have to do is, does this middle term equal twice the product of the two numbers that we just found, the two expressions we just found? Does this equal to twice 3x, 2 times 3x times 5? Does it? Yeah. 15 times 2 is 30, so yeah, check mark. So this ends up being 3x plus 5 squared, which is the same as what we found over here. So x squared minus 38x plus 289. Well, x squared is the square of x. 289 is the square of 17. And since this is negative, that means if we're going to get anything, it's going to be x minus 17 squared. But in order for this to be a perfect square, this 38 has to be twice 17 times x. Twice the product of these two numbers, these two things we just found. Well, twice times 17x is 34x. So this is a no-go. We can't factor this into two binomials. If it had been 34x, or negative 34x, then we'd be good to go. It'd be x minus 17 squared, right? Because negative 17 times x times 2 is negative 34x, and that's the middle term. So if you figure out what the first term and the last term are squares of, multiply those two and double it, and if that's the middle term, the x term, then you know that this is a perfect square. In the next video, I'll talk about solving quadratic equations using all the tools that we've used so far. But for now, that's all I have. See you next time.